Colleagues, can you please mute your microphones? Mm-hmm. Good afternoon, everyone. Good afternoon. Good afternoon. My name is Cheryl Garrix Lloyd, and thank you so much for joining us this afternoon. Welcome to our Infection Prevention Control and Non-Nursing webinar series, number 2. So we thank those of you who have joined us and you have registered. We will be having other persons in, and today is the first of our 6 sessions. So just a few public service announcements before I hand over to our moderator for this afternoon. I am asking everyone who's here and or your colleagues, if they are joining, people need to join using their full names, Christian name, surname, and they need to have it changed. If you have been let into the room without those names, I'm going to put you back in the waiting room. We are using your attendance as a record for your CE hours. I cannot give hours to a KL, to an AG, to a Samsung, to an iPhone. So we're asking you to remind everybody, and if you haven't changed your name, please go ahead and do so. We are going to be doing the register as we go along. And if you're only Venice, there can be many Venices, so you can't just put one single name. Thank you. So today's session, we will have 2 presentations, and then we will have just a little bit of something in between and a little something at the end. So we hope you'll be learning and benefiting. I've also asked, I'm reminding us that all the recent studies in the last several years have shown that nurses are considered most honest. If you did not receive the Zoom link from Omega Kappa, you are not supposed to be in here because each person was instructed not to share. If you did not follow the instructions and send an email with your information after you registered, or did you upload it in the registration form, then perhaps that is why you have not heard from us. So I know you may need to share with some persons because they may be wondering what has happened. We are doing the behind the scenes work for all the persons who are joining the session. So just a little housekeeping. We'll remind you again as we go along, but welcome everybody and thank you so much for joining us. And I will hand over to our moderator, Mrs. Heather Silvera. Persons don't need to write their names in the chat. You just need to ensure you are signed in with your correct name. If anybody is joining us over on YouTube, welcome to you as well. Go ahead and type your names in the chat on YouTube as well so we can make a note that you are there. And we remind everybody, last but not least, please have your microphones muted throughout the session unless we get to the question and answer section and you are acknowledged when you've raised your hands, or you may go right ahead and type your questions in the chat. So if you want to make notes as you're going along so you don't forget. Over to you, Mrs. Silvera.
Thank you, Mrs. Garrix Lloyd. Good afternoon, ladies and gentlemen. Let me first apologize for not showing my face. My camera is not working at this moment. So let me just add my bit of welcome to you all to our second Infection Control webinar series. My name is Heather Silvera, and I am the treasurer of Omega Kappa. Let me introduce to you our first presenter, who is Mrs. Sharika Sachel Knight. Mrs. Knight is a graduate of the University of the West Indies, where she completed a Bachelor of Science degree in microbiology in 2005. She also pursued a Master of Science degree at the Northern Caribbean University in biology with microbiology emphasis in 2015. She worked at Red Stripe between 2005 and 2010. She also worked at the National Water Commission as a microbiologist, and she worked also at Surge Island Dairies Limited as a food safety Officer. She is currently employed at the Bureau of Standards Jamaica as the Food Safety Modernization Coordinator. I introduce to you now, welcome Mrs. Sharika Sachel Knight. Thank you.
Good afternoon. Thank you so much, Mrs. Silvera, for that introduction. And thank you to the Omega Kappa chapter of Sigma Theta Tau International Honor Society of Nursing for the invitation of doing a presentation today. It is absolutely my pleasure to be here, and especially to talk about a topic that I think is so important, just because of the importance of microorganisms to us as humans, to our environment, to production, to industry. And certainly I'll throw in a plug right here to say, I think microorganisms and microbiology became so much more important to me when I became a mother a few months ago. And this was when I started to wonder if the baby will be all right, if he's going to get an infection from bacteria. And so you think about him doing his shots, or you think about him having clean hands because he's now putting just about everything in his mouth. And so I think that was when microbiology really became live and direct for me. And so I'm just really thrilled to be here and to be a part of the session and to share what I call just a background about microorganisms and the role that they play in our lives and in society. And for a moment, if we could, I'm going to invite us to think about a world without microbes. And just very quickly before I delve into my presentation, if I may just get a few responses from you, you're listening to me, you're going to hear me for a little while. But before I delve into it, if I may indulge your participation for a little bit, can you imagine for a second what the world would look like or what it would feel like if we did not have microorganisms? If you can just throw in the chat what you think about it. I'll give you one, for example. Certainly, we would not have COVID-19. So that is one of the quickest things that I want to throw out there. Imagine not having to deal with COVID-19 as we have had to deal with it over the past almost going 2 years now. Any that you may have, I just want a few seconds. If you may indulge me for a minute before you hear me talking for another half an hour or so or more. What would the world be like without microorganisms? What would you be happy not to have to experience the world of microorganisms? Were they all to disappear? Just a second, let me hear what you think while I switch over to the next slide. All right, nobody taking me on just yet, but not a problem. Think about it a little bit longer as we go. Okay, I'm seeing something, no infection. Somebody says less persons would be sick. That is so true. Mortality rate will be less. That is true. There would be no more flu season. That would also be true. So there are things that we could, so to speak, enjoy. Yes, there would be positives and there would be negatives, certainly. But as I mentioned, we can quickly think of a few things: less infant death from CLEV. All of some persons saying it would create balance, less worrying if you didn't have certain microorganisms to think about. Absolutely true. All of these are fantastic answers that you have given. So thank you so much for indulging me for a few seconds. I want to highlight the importance of microorganisms to the genesis of the world as we know it. And no, I'm not going to go into a deep philosophical conversation about how the world came about or anything like that. I'm just going to zoom right into the focus of microorganisms to the early world and how the world came about. And we're going to look at the historical significance of a few events, the story of the evolution of microbiology as a study. And I'm going to dive right into looking at the morphology of bacteria. No, bacteria just as a set of the microorganisms that exist. And I will not use the time to go through all of the different morphological features of all of the different microorganisms. So I'm going to zoom in a little bit on bacteria for a few seconds. And we're going to reflect on the importance of microorganisms. And that reflection has already begun, because you have already begun to express what it would be like without microorganisms. And you're right, you're stating that there would be a balance. You have some positives, you have some negatives. There would be no need to sterilize, is what one person is saying, etc. So certainly the reflection has already begun. Now, scientists over time have tried to get an understanding of how old the Earth is. How long has the Earth been around? And many have postulated that Earth was formed about 4.5 billion years ago. And within the next billion years, the first cellular life form, which are microbes, are said to have appeared. Now, measuring the age of rocks on the moon and meteorites that are found on Earth, scientists estimate the Earth consolidated about 4.5 billion years ago. Some texts will say 3 billion, others will say 4. Remember, they're trying to get a sense of the age of the Earth. But what is true is that in 1977, there was a discovery of microbial fossils in certain kinds of rocks that were rich in silica, called Schertz, C-H-E-R-T-S. And provided for scientists the first evidence of primitive cellular life. Therefore, I think we can conclude by all of the evidence that has been postulated and found that microorganisms, are the oldest form of life on Earth. And this is an example or a drawing of the microbial fossils that were found in the sedimentary rocks in 1977. Now, what is true is since early life, microorganisms have evolved and diversified to occupy virtually every habitat on Earth, from oceanic geothermal vents to the coldest of Arctic ice. Microbes are an extremely diverse group of organisms. And in terms of species, they represent the most abundant life forms on this planet. Very successful microorganisms and can survive extreme conditions. And these are called extremophiles. Some microbes can survive in temperatures above boiling point. Others thrive in freezing conditions, and yet they die at room temperature. Some can use substances like oxygen to produce energy. Some use other substances other than oxygen to produce energy, like sulfuric acid, iron, arsenic, uranium, and flourish in chemically dangerous environments that are harmful to humans. And they remove toxins from these environments. So as you can imagine, the ability of microorganisms to use these various types of substances has been exploited by humans. And we've seen them in many different applications. For example, bioremediation. So I'm just showing some of the examples of the places that we have mentioned thus far. This is a geothermal vent, deep sea, and is a picture of some ice in very Arctic areas in one country. What is also true is humans have been living with and using microorganisms for much longer than we have been able to see them. Now, worldwide, people have enjoyed fermented foods and beverages like beers and wines, bread, yogurt and cheese, pickled vegetable, all of that, for all of recorded history. But discoveries from several archaeological sites suggest that even prehistoric people took advantage of fermentation to preserve and enhance the taste of food. Archaeologists who were studying pottery jars from the Neolithic village in China found that as early as 7,000 BC, people were making fermented beverages from rice, honey, and from fruit, 7,000 BC. So it is quite likely that in those times, persons learned about fermentation quite by accident. Maybe they left some milk lying out and it started to curdle and they kind of hazarded a taste of it. Perhaps it was that somebody had left out some wine, some grape juice or something. They left it out. And when they tasted it, they realized that there was a nice aroma, a nice taste to it. And so quite by accident, fermentation could have been discovered all those years ago, but later on, persons learned to harness the power of fermentation to make products like breads and cheeses and wine. And what we're seeing here on the screen is that historical evidence suggests that humans have had some notion of microbial life since prehistoric times and have used that knowledge to develop foods as well as to prevent and to treat disease. We're looking at a picture or a depiction of Egyptian bakers, and this is dated 2100 BC. We're talking before Christ, BC, long time, where Egyptian bakers used yeast to make bread, and this is evidence of excavated tools. What it also showed was that there was a complex process that was used to ferment cereal to make beer, right? So from a very, very long time ago, even though we could not see the microorganisms, certainly there were certain processes that were being done. Even if we couldn't say how it was being done, we were capitalizing on them. What is also important is that, again, even though we couldn't see what was going on, we didn't see microorganisms back then, but even several ancient civilizations, they appeared to have had some understanding that disease could be transmitted by things they could not see. Now, this is especially evident in historical attempts to contain the spread of diseases. For example, you're looking at a depiction of a story from the Bible, which basically refers to the practice of quarantining people with leprosy and for other diseases. People are realizing that, okay, so diseases could be communicable. So if I kept some persons away, if I quarantined them, then it could prevent the disease from being spread. So from a very long time ago, again, even though the concept was you're not able to see these things, something is causing the disease. And later on, we will see how these things became seen and became experienced and explained. Again, in the story of microorganisms, I want to bring to our attention a gentleman by the name of Thucydides. He's a Greek philosopher and historian, and he is considered the father of scientific history. And here is why. He advocated for evidence-based analysis of cause and effect reasoning. It's not just because of nothing while people are getting sick. There has to be something that has caused this. And what was important is when he became a part of history, when where there was an Athenian plague, and that plague, let me just jump in right now with a quick thought. It's not no we're having different things happening and persons dying from it. History is rife with stories upon stories of nations, of thousands of persons who would have been killed because of some kind of a plague or disease that attacked or infected persons at that time. And here we are seeing a depiction of the plague in ancient city, which was a picture, an artwork that was done by Michael Swartz, and it is believed to depict the plague of Athens. So even at that time, during the 430 to 410 BC, long time, they were having plagues and issues, and it killed 1/3 of the population of Athens. Now, Thucydides himself, he survived the plague. But what was important, he made an important observation. He noted that the survivors did not get reinfected with the disease, even when they were taking care of actively sick people. And this observation shows that as early as those times in 430 to 410 BC, there was a kind of an understanding of the concept of immunity. So at first we're talking about quarantine, then we're talking now about immunity. So again, we couldn't see it, but we were realizing that something out there was actively causing the diseases, and it was menacing to the society and very, very debilitating to what was happening. The Greek physician Hippocrates, he is known as the father of Western medicine. Why is he important? Unlike many of his ancestors and contemporaries of the time, he was not of the notion or the idea that disease was caused by some supernatural force. It just happened. Many of his predecessors believed that disease was even caused by what they call bad air. So the air was bad. A theory of miasma, M-I-A-S-M-A. So the air is bad, and that is what is causing the disease. Now, even though at the time they may have developed hygiene practices that was built on this idea, it was not entirely correct. Other persons believe that, boy, the diseases and the illness came about because of what? Sin. You were disobedient to God and he caused the sickness. Others believed that it was witchcraft that was causing these diseases. Others believed it was magic, the supernatural, that was causing all of these things. But Hippocrates said, no, listen, let's look at it from a natural point of view. Diseases had real causes within patients. Something was causing it, and it was either within the patient or it was in their environment. So he was onto something. Something was causing the diseases. Now, Hippocrates and his heirs are believed to have written what is called the Hippocratic corpus, which is the collection of texts that make up some of the surviving medical books that exist now. And he is also credited as the author of the Hippocratic oath that new doctors take when they're making their pledge to diagnosis and treating patients without harm. So what is important now is we're going to begin to look at now microorganisms becoming visible and just how that caused a tremendous change in how we were able to fight infection and control diseases, because now understanding was just not something that we couldn't understand or couldn't explain anymore. We have evidence to suggest that this is how it was, what is causing the diseases. And these three gentlemen, I want to highlight very briefly their contribution to the history of microbiology. And you may have heard their names already: Anthony van Leeuwenhoek, others have him as Antoine Leeuwenhoek, Leo Pasteur, and Robert Koch. Now, it is thought that microbiology actually started with one Anthony van Leeuwenhoek in 1679. He is thought of as the improbable father of microorganisms. You know why? He was actually in the textile business. And then Mr. Leeuwenhoek somehow learned how to make microscopes. He used the glass and made some microscope that had some fantastic magnification. And using these, he was able to actually make a number of very important scientific discoveries. Now, can you imagine? He is he's in the textile business, but he had other interests. And that interest is now a part of the history of microbiology. His microscopes were so finely tuned that after he discovered bacteria, this type of microorganism would not again be observed for over 100 years. The man was that good. And as a matter of fact, is what actually said that the secret to how he made the microscope and being able to see these microorganisms so tiny actually died with him. So he was the first to describe a single-celled microorganism that he called animalcule. And what he did was he took a sample of plaque from his teeth, and according to Science Learning Hub, he made certain comments. And I'll share that with you for a sec. It says, I then most always saw with great wonder that in the said matter there were very many little living animalcules, very prettily moving. The biggest sort had a very strong and swift motion and shot through the water or the spittle like a pike goes through the water. The second sort that this is the animalcules or the microorganisms that he's describing, you know. The second sort, he says, oftentimes spun like a top. And there were far more of those in than others that he would have observed. So this is in 1676, Mr. Hook describing what he is seeing when he looked in the microscope after having some scrapings from his teeth put under the microscope. And it was later on that Mr. Louis Pasteur and then Rubbercock, they also made some very important discovery. Now, let's jump to Mr. Rubbercock. He was a pivotal figure in the golden age of microorganisms. He was said to discover that the bacteria that caused anthrax, it was said that he was the one who discovered the bacteria that caused anthrax, septicemia, tuberculosis, and cholera. And because of the method that Koch owned and did a great job with fine-tuning, his method enabled others to identify many other important pathogens. Now, thanks to his contribution, he is sometimes referred to as the father of bacteriology. His first important discovery of anthrax was that there was a disease that was causing death of a very large number of livestock. And in humans, it was causing death as well. And some rod structures were observed in the blood of the infected animal, but still they were not sure what was the cause of the disease. He found that the disease could be spread by the blood of an infected animal, and he hypothesized that it was caused by a living bacteria. And
sorry, I think she got, Sharika, are you back with us?
You're muted, Mrs. Knight.
I realize, thank you so much. Yes, I am back. Let me just jump right back into the presentation. Okay, so we're talking about Rubbercock. So basically, he developed a technique for observing bacterial growth, and he saw that the anthrax could actually produce spores that survived drying out. But then when you put these spores in environments that were moist or amenable to the bacteria, they actually grew again. So he realized that contaminated soil could remain toxic for many years, especially if these spores are found. So he basically, when he was trying to explain how it is that the microorganisms are responsible for causing the disease, he came up with some conditions or some steps that we know them as Koch's postulates, right? And the first step is the microorganism must be identified in all individuals that are affected by the disease, but not in healthy individuals. So if you had sick cows, the microorganism must be present in the cows that are sick, but is not in the cows that are healthy, right? Then the microorganism can be isolated from the diseased individual and grown in culture. So you're able to isolate that microorganism and grow it. When that is introduced into healthy individuals, the cultured microorganism should cause the disease. That's the third one. And the fourth condition is the microorganism must then be re-isolated from the experimental host or the host that was inoculated. And the microorganism must be found to be identical to the original microorganism. And of course, I can understand just how important those particular steps are, because later on we see that this is really how diagnosing diseases has truly been elucidated. It is because we're able to isolate and identify the microorganisms, and because we're now able to see its effects in other organisms that would have been impacted, that we're able to say it is that particular microorganism that has caused the disease. And this is the first step in being able to have any kind of a recourse, to have any kind of a medicine or any kind of a cure for whatever the disease is, once we're able to identify the microorganism. That is the first step. And so Mr. Koch, as well as Leo Wenhoek, they had a tremendous impact on the history of microorganisms. I won't bore you with more details, but I just want to jump very quickly into what Mr. Louis Pasteur did. And he was important because when everybody else was pulling from thin air to say diseases were caused by by supernatural forces and things that we didn't know about, he actually helped to formulate what is known as the germ theory. He did a series of experiments to discover why, for example, wine and dairy products became sour. And he found that bacteria were to blame. And so he called attention to the importance of microorganisms in everyday life. And he stirred scientists to begin to think that, listen, if the bacteria can make the wine sick, quote unquote sick, then perhaps isn't it possible that they could be responsible for causing humans to be sick? And that was an important question that he asked. He disproved this theory of spontaneous generation. And what he did was he had some flasks that he designed, and he left them in the open air, and the flasks had broth in them. But the flask had a curved neck. So when it was open to the air, what would happen is the microorganisms would fall in the neck of the flask and not in the broth. And so what happened? The broth did not become infected. It did not have anything growing in them. So it was not contaminated, I beg your pardon. And so Pasteur's experiments put to rest the notion that spontaneous generation existed. He allowed persons to understand that microorganisms were in the air and they could cause diseases. And so Pasteur postulated the germ theory of diseases, which states that microorganisms are in fact the cause of infectious disease. And so I just wanted to bring to highlight these three very important gentlemen and the role they played in the history of microorganisms. Because if we couldn't see it, If we didn't believe that it came from a specific microorganism that caused the disease, and if we weren't able to isolate them to say, this is the microorganism that caused a particular disease, then I think you will agree with me that we would be in problems and we wouldn't be able to find out what is causing the diseases that are impacting on our lives so hard, so devastatingly. And so very quickly, we jump into a definition of what are microorganisms, because we've been talking about them for the last few minutes. And they are organisms and acellular biological entities that are way too small to be seen clearly by the unaided eye. So they can be fungi, protists, bacteria, archaea, virus, viroids, satellites, all of these can form are microorganisms. Yes, you may have fungi and other things that their fruiting body or other parts of it can be seen with the naked eye, like, for example, the mushroom of a fungus, but predominantly the features are microscopic. And these are the organisms. So microbiology is the study of microorganisms or microbes, and they are of a diverse group of generally minute or small life forms that include, as we said before, bacteria, archaea, algae, fungi, protozoa, viruses. And the field is concerned with the structure, function, and classification of such microorganisms with ways of both exploiting and controlling their activities. And very early, we were already speaking about, even though we couldn't see what they were, we were already exploiting the microorganisms because of their functions and what they were able to do. I had mentioned before that I'm going to jump real quickly into looking at some of the shapes that are associated with bacteria. So we're going to zoom into bacteria because there are many microorganisms that exist. So we have some that are round shaped called coccus. We have others that are rod shaped. Some are curved. Some occur in pairs. Some are cucibacilli, so it's a little bit of a round, elongated shape. Some are curved, like the Vibrio, like the microorganism that caused cholera. You have some that exist in tetrads, some that are in pockets of 8, 16, or 32 cells. Others have some shape that we're trying to figure out what they are. They're pleomorphic. Others are spirals. So there's a whole host of different shapes, morphologies that can present when we're looking at bacteria. And these are some examples of well-known microorganisms, bacteria such as Streptococcus pyogenes that cause strep throat, Streptococcus pneumoniae, which causes pneumonia. I thought this was interesting, Micrococcus luteus, which is known to cause armpits to not be so well odored, let's put it like that. We talked a little bit about anthrax, which is a Bacillus anthracis. That is the name of the microorganism. We have those that cause cholera, like Vibrio cholera here, as we're seeing on the screen. I want to also bring to our attention Staphylococcus aureus, which even though it naturally occurs on the skin, it can cause sinus infection and food poisoning because of the kind of toxins that exist. So even if when food is left out on the table at room temperature, it can cause these toxins to become produced. And so I don't even realize that the food is spoiling, because sometimes there's no smell. So you don't even have the evidence, hard evidence that the food is spoiling, but something is happening. And so these are important microorganisms. What is also true is when we think of microorganisms, sometimes the very first thing we think of is infection, the pathogens, those that cause infections. Because when we look around, that is the most devastating thing that we're seeing. We're seeing the COVID and its impact. We're seeing what is happening with other diseases. We're seeing hospitalization. We're seeing the ill effects. And the unfortunate truth is microorganisms are not all bad. Microbes are found throughout the human body, in the gastrointestinal tract, on the skin, the saliva, the oral mucosa, the conjunctiva. These bacteria are acquired during birth and the first years of life, and they live with us through the rest of our life. So when people think about microbes, as I said before, the easiest thing to think about is diseases. But majority of the microorganisms that we are coming in contact with are harmless and actually help to maintain our health. However, when the body's defenses are impaired, then it can cause diseases. And therefore, I think you'll agree with me that it is a very delicate balance. And this is just a depiction of the various microorganisms that can be found naturally on the body. And I just wanted to let that stay for a little bit. Want to realize the different types of microorganisms that are associated with the human body and the fantastic function that they have. Now, I asked us from the very beginning to think about a world without microorganisms, and we did that for a second. Now, in 2014, microbiologists Jack Gilbert and Josh Newfield, they published a thought experiment in which they imagined what it would be like if all the microbes in the world suddenly vanished. And this was published in the Public Library of Science, and it caught the interest of many reporters who in later years ran pieces on this thought experiment. And basically what they came up with are some of the very same things that you had come up with when I asked the question earlier. So there would be no microorganism, there would be no pathogenic microorganism, certainly. There would be no disease, no AIDS, no yeast infection, no Ebola, no athlete's foot, no malaria, and the list goes on. No foodborne illness, no waterborne illness, no hospital visit for the infection. Somebody said no need to sterilize because we have a disease-free and microbe-free world. Sounds good? Maybe. No disease sounds really good. What about food? There will also be no spoilage of food. It is estimated that one third of the world's food was lost or wasted every year. And it is estimated that this is some 936 billion US dollars that is accounted for this amount of waste. How many of us out there have contributed to food wastage? Can I stick my hand up? There are many times when we have the tomato, just like the picture, we have the things in the fridge for too long. We cook a big pot and yet we know we're not gonna eat it all off, so we end up throwing some out. We know that the fruits are on the table and we have them there till them spoil. All of these things, we contribute one way or another to it. So it is either spoiled or is lost or is wasted. Can I jump in again and say that my 11-month-old is throwing the food all over the place now? So can I tell you I contribute to food wasted because of him? Anyway, I'm not going to blame him at all for all of that. But there was a research service, the Economic Research Service of the US Department of Agriculture. They estimate that basically a total of 133 billion pounds of food went uneaten with an estimated retail value of $162 billion. That sounds like a lot of money, right? Because it is. This translates into 141 trillion calories, whole heap of calories of food, of available food that is not consumed. And this was a report done in 2010. In 2011, the Food and Agriculture Organization of the United Nations presented similar estimates that 1/3, as we mentioned before, of the world's food was lost or wasted every year. So food loss and food waste has indeed become an issue. So imagine, we don't have any microorganism that is causing the rotting of our food, and we're not having this billions of dollars wasted, and we can put it into other things, right? Like fixing our roads or other things that are important, right? Because it's a lot of money that we're talking about. So without microorganisms, we have no food wasting, and that is a fantastic thing. Can I also get another, give another perspective of a world without microorganisms? Biogeochemical cycling would stop. Nitrogen cycling, all of the sulfur cycling, everything. So all of these compounds being put to good use in the environment and in the soil, and plants using the nitrogen, all of that, that would stop. Plants would die. Cows and other ruminants would die. Just one line of how things can be impacted. So after that, do you think the human being would be able to survive a very long time? Or what if the quality of life would exist at that time? Could you imagine a world without cheese for those cheese lovers out there? Could you imagine a world without antibiotics? But then if we have no diseases, we would need that, right? Could you imagine a world with certain kinds of foods? Could you imagine a world that if we had an oil spill, we would not be able to remove that oil from the ocean or wherever it is that it was spilled? Can you imagine not being able to have degradation or things breaking down? I mean, I don't know about you, but when I think about the pros and the cons, can you imagine your waste building up and there's no treatment of wastewater? Can you imagine if we couldn't do certain research because we didn't have the kind of microorganisms as the vehicle to get the research done? Can you imagine that world and what it would be like? There are many things that we would not be privy to at this time. And like Kermit jumping right there in the screen, I think you'll agree with me that probably have a little bit of panic if we were to wake up tomorrow and find that microorganisms have suddenly disappeared from the world. And so I want us to just recap for a little bit. Microorganisms are said to be the first living organisms on Earth. And I think you will agree with me that they are very important for the survival of humans, animals, for environment, for production, for everything that we can think of, many things that we can think of. Microorganisms contain incredible metabolic and genetic diversity. And as a result of that, there are many substrates that they can use for energy. And there are many, many applications that we have benefited from as a result of this. Microbes are important for the sustenance of life. We mentioned from the very beginning that they are the most abundant and diverse group of organisms. And microbes are beneficial to society by their production of food, beverage, antibiotics, vitamins, etc. So there's a plethora of things that are produced as a result of microorganisms. And so at this time, I just want to reiterate one more time that microbes are so very important. And so to think of a world that does not have microorganisms would be a world that it would be lacking in many, many ways. And so even though there are concerns with disease, I am glad for the path that microbiology has taken over time and the many persons who have contributed to the world of microbiology. And so now we are able to have diseases cured. Now we're able to offer help to persons who may have been infected because we have a better understanding of the microorganisms that play a role in disease, causing diseases. And so I want to thank you so much for your time, for listening, and for sharing with me your thoughts as we took a journey to reflect on the importance of microorganisms and the role that they play. And I think you'll agree with me that to imagine a world without microorganisms is to imagine a world that will have a lot of shortcomings. So at this time, you've heard me speak for the better part of more than half hour, almost 40 minutes. Let me hear from you. Do you have any questions? Do you have any comments? I'd love to hear from you at this time.
Okay, Mrs. Knight, a wealth of knowledge, colleagues, we have just received. Thank you so much, Mrs. Knight. Well presented. And on behalf of all our nurses on the platform, I just want to say thank you. Are there any questions at this time? You can go to the reaction and click the raise hand icon, or you can just type it in the chat. Any questions at this time? Let me look. I'm seeing, thanks for a wonderful presentation.
You're most welcome.
Okay. It was very clear, Mrs. Knight. I'm not getting any questions at the moment.
I hope it didn't mean that I put them to sleep.
No, I doubt it very much. Informative history lesson. The comments are coming in. Informative history lessons. Okay. Thanks again.
Sure.
Well researched and presented. Thank you. Okay. Thank you so much. All right, we will move right into our second, clear and concise. Yes, the comments are coming in. All right then. Thanks again, Mrs. Knight. Okay, we will now move into our second presenter. He's Dr. Jermaine White, former school captain at Jamaica College, graduated from the Latin American School of Medicine with first-class honors in Cuba, and he graduated with his Master of Public Health and Health Management with distinction from the University of the West Indies. He's a physician and a surgeon, and he lectures in the UWI School of Nursing. I welcome at this time Dr. Jermaine Knight.
I see you marrying me after Mrs. Knight to Shedrika. It's White. But thank you. Thank you so much, Heather.
Dr. Jermaine White.
It's fine. Pleasant afternoon again, everyone. Thank you for having me. I was here last year and I was actually surprised that you guys asked me to come back again this year, because the class I gave last year was more a class on genetics than on anything else. But I've decided to, take a second approach to our presentation this week. And so, or this year rather. And so I will be presenting today for you guys. Again, thank you, Heather, for that lovely introduction. I've been having a running day, teaching all day. So I am sorry I missed the first presentation, but I'm just gonna jump right into our presentation for today. Now, what we're gonna be doing is actually more of a talk than anything else. We're looking at MDROs, which are essentially multi-drug resistant organisms. And in terms of disclaimer, I have none. And at the end of today's session, we will most definitely have understood or defined what are MDROs, understood the basic principles that contribute to resistance of these organisms. And we're gonna be reviewing the basic, having a basic understanding of the impact of antimicrobials on MDROs. And we're gonna understand the basic principles of microbial resistance, as well as exploring just some selective MDROs, looking at them in finer detail and discussing methods of prevention. And of course, we are going to be taking more of a public health perspective concerning this and what we can do for the future. Now, in terms of a definition, multi-drug resistant organisms, MDROs, They are microorganisms predominantly, let me just get my points out here, predominantly bacteria that are resistant to one or more classes of antimicrobials. Now, these are, although the names of certain MDROs describe resistance to only one agent, for example, your MRSA or your methicillin-resistant Staphylococcus aureus, and your vancomycin-resistant your enterococci, these pathogens are frequently resistant to most available antimicrobial agents. And this definition was coined by WHO in 2013, and there has been no change or little change since. Now, in addition to the MRSA and VRE, certain gram-negative bacteria, including those producing extended spectrum beta lactamases, which we will look at a little further on in our conversation, and the other that are resistant to multiple classes of antimicrobial agents are of particular concern. So extended spectrum beta lactamases, which are usually enzymes that and counter your beta lactams, right, are organisms of concerns. Now, your drug-resistant pathogens are a growing threat to all people, especially in the healthcare setting. And just looking at, because we have, data that we can actually extractable data. Each year, about 2 million patients in the United States gets an infection in a hospital. And of those patients, about 90,000 of them die. Now, as a result of their infection, more than 70% of the bacteria that causes hospital-acquired infection are resistant to at least one of the drugs most commonly used to treat them. So essentially, persons infected with drug-resistant organisms are more likely to have longer hospital stays, and they require treatment with second or third choice drugs. And that may be less effective or even more toxic, and sometimes, or oftentimes, I should say, more expensive. From the public health perspective, one of the things that we would want to take into consideration is the fact that the average length of stay for a patient within the healthcare setting, the cost to treat that patient, the longer they are in hospital, of course, is going to be more as time progresses. Additionally, the cost to treat a patient, for example, at the primary care setting, is going to be way less than the cost to treat a patient at the secondary level. And even worse, if we have to transfer that patient to an ICU setting where the cost to treat sometimes is 10 times what it is at the secondary level. I remember the NHS in the UK did a study on the cost to treat. And for example, the cost to treat a patient at the primary care level was something like $127. This was a study that was done in 2018. And the cost to treat a patient at the secondary care level for a community-acquired pneumonia, for example, and we're not speaking about conditions that entertain a multi-drug resistant organism. We're talking about something as simple as your strep pneumonia, right? $127 per day to treat the patient at the primary care level. At the secondary care level, it would cost around, if I'm not mistaken, 327 or 300 and something, like 3 times the amount. But when the patient goes to the ICU setting, it costs over $3,000 per day. So it's over 10 times the cost. And of course, in Jamaica, we are under the universal health coverage or signatories to universal health coverage. And so the cost to the patient sometimes is not directly passed on, but it does cost the government to treat patients. So even as healthcare workers, we have to be, very good stewards when it comes on to our clinical vigilance. So what is the clinical importance of your MDROs? Right? In most instances, MDRO infections have clinical manifestations that are similar to infection caused by susceptible pathogens. And here you'll hear me use the term susceptible pathogen as opposed to MDROs. And for example, if we're looking at, for example, your MDROs concerning your enterobacteria, we're looking at like your Klebsiella, your Pseudomonas and those sort of organisms. And so you have your MDROs and you have your susceptible organisms. However, the option for treating patients with these infections are often extremely limited. So when you have patients with MDROs, you don't really have much of a choice. I know, for example, at our current hospital, University of West Indies, for patients who are in the ICU setting with MDROs, what the current drug of choice or drugs of choice is they throw linezolid, they throw polymyxin B, and they throw vancomycin at everything. Woe be unto us if we have a vancomycin resistant strain. Vancomycin is of no use. And basically the cost of linezolid and polymyxin B is extremely expensive, right? So although antimicrobials are now available to treat for the treatment of MRSA and VRE infections, resistance to each new agent has already emerged in the clinical isolates. And so similar therapeutic options are limited for your extended spectrum beta-lactamases, right? Producing isolates of gram-negative bacilli. And so we have a very growing spectrum of bacteria that are growing resistant even to the modern modalities of treatment concerning your MDROs. Now, these limitations may influence our antibiotic usage patterns in a way that suppress normal flora and create favorable environment for the development of colonization when exposed to potential MDR pathogens. And this is known as what is called a selective advantage. Now, in terms of, I already mentioned the increased length of stay and the cost, but we also have to look at the mortality, right? And there is also a growing trend, which we will look at a little bit later, of what is known as community-acquired MDROs. And so the mortality associated with these cases have been associated, are actually higher, right? So the type of level of care influences the prevalence of MDROs. So you'll find, and this is sort of a biased statement. I don't know if anyone can probably tell me why you think this is a biased statement, that the type of level of care influences the prevalence of MDROs. And as I said, this is a talk, so I will call or ask questions, and don't be afraid to answer. This is where we just flesh everything out, right? But why do you think the level of care influences the prevalence, or should I say, dare say, the incidence of MDROs? Can anybody say why? So for example, ICUs would have a higher number of MDROs than, for example, in primary care. I guess everyone is shy, and that's fine. Well, obviously, testing is the most adequate response right there, because the cultures, the frequency at which cultures are done, right, to identify organisms will actually be done at a more frequent level or basis in the ICU setting than it would be in the primary care setting. Now, and of course, tertiary care settings, which are usually, specialist facilities, right? So your MRSA was first isolated in the United States in 1968. And by the early 1990s, MRSA accounted for 20 to 25% of Staph aureus isolates from hospitalized patients. That's a quarter of your hospitalized patients. By 1990, from 1968, had, a MRSA infection. Now, in 1999, MRSA accounted for more than 50% of your Staph aureus isolates from the patients in ICU, and the National Nosocomial Infection Surveillance System in 2003 approximated that about 59%, basically 60% of Staph aureus isolates, right, in ICU were as a result of MRSA. Now, what is that saying? There is a growing trend from the first discovery of the organism from 1968 until in the 2000s, right? There has been a growing increase of that number. Now, we have not seen further growth, to go all the way to 100% now, because there are certain responsive systems that have been set in place, and our health system must focus on being preventative or rather than being reactionary, right? So this is just a graph representing the percent of resistance that was noticed with your MRSA. And from the time it was isolated first in 1968 until it peaked in about 1999 thereabout, right, where it had about 50%, right? And then it has now in 2003, had about 59.5%, essentially 60%. We have seen a stable increase, right? And if we were supposed to do a linear graph, right, we would see that there is a steady increase, right? Now, in terms of your vancomycin-resistant enterococcus, your VREs, a similar rise in the prevalence occurred from 1990. A similar prevalence has occurred in 1990 to 1997. The prevalence of VRE in your enterococcal isolates from your hospital patients increased from less than 1% to approximately 15%. And remember that these would be your gram-negative organisms. Now, in your VRE, it's accounted for almost 25% of your enterococcus isolates, and essentially 28.5% in 2003. And so we see a similar trend, right, that there is a linear increase in your patients with your vancomycin resistant enterococcus. Now, in terms of your gram-negative resistant bacteria, right, your extended spectrum beta-lactams, things like your fluoroquinones and your carbapenems and your aminoglucosides also have increased in prevalence. And so we know the cautions that we have in terms of use of our fluoroquinones, for example, is we have limitation in using it below the age of 18. We are very cautious in using our aminoglucosides because of the impact that it can have on the patient's hearing and causing sensory neural loss. And so, you know, because of the increase in these their extended spectrum beta-lactams, which would ordinarily in your susceptible organisms provide coverage for these patients, right? We have to now rely on these drugs. And so, you know, the impact of these drugs, we have to be careful as well. Now, for example, in 1997, the Century Antimicrobial Surveillance Program found that among your Klebsiella pneumoniae strains isolated in the US, resistant rates to ceftazidime and other third-generation cephalosporins were 6.6 and 9.7 and 5.4, as well as 3.6 for your bloodstream pneumonia, wound, and your urinary tract infections, respectively, right? We see that the patients who had sepsis, for example, had 6.6, that corresponded to about 6.6% of the patients had some extended spectrum beta-lactamase, conditions going on there. And then you had your pneumonia, right? Your Klebsiella pneumonia, which had the highest of 9.7, having infections with these extended spectrum beta-lactamase. Now in 2003, approximately 20.6, so this is between 1997 now and 2003, right? Approximately 20.6% of all Klebsiella pneumonia isolates from the NNIS ICUs were resistant to these drugs, right? And so in a very short period of time, right, less than 10 years, we had patients, right, who were once sensitive to these drugs, were no longer sensitive to drugs like carbapenem, aminoglucosides, and your fluoroquinones. And we're talking about, you know, drugs like your levofloxacin as well. And I want to point out that this is rather significant. So here, in terms of your third generational cephalosporin resistant Klebsiella pneumonia, so we're looking at our roquefin principally, or ceftriaxone, right? Here in between 1995 and 2004, we saw an increase, right, a fluctuating increase in the resistance of that organism, right? So here, in terms of your fluoroquinone resistant Pseudomonas aeruginosus, which among your intensive care patients, right, there has been a steady increase, but that has also declined, right, in 2004 and has been relatively stable. Now, the whole point of even talking about multi-drug resistant organisms, and we looked at, you know, okay, multi-drug resistant organisms are on the increase. Everyone knows that, right? You didn't need me to come here today to tell you that multi-drug resistant organisms are on the increase, both from the gram-negative and the gram-positive spectrum. And we have further and further, more advanced, rather, drugs that are, you know, these organisms are becoming more and more resistant to them, right? So we must do something, and we must be proactive. We can't be reactionary. We have to be at the front. And so us as the health team, I don't really like to use the term clinicians, because clinicians sometimes has a bias to it, right? But as the health team, right, we have that responsibility, and that campaign to prevent antimicrobial resistance rests in our hands. Now, in terms of the risk factors that promote antimicrobial resistance within the healthcare settings, these include the extensive use of antimicrobials in the transmission of infection, right? And so, the transmission of infection of susceptible hosts. It should have been down here, right? So I know that on the end of the extensive use of antimicrobials, we include everyone, because we have not just the clinicians who prescribe, and this is not just in the Jamaican setting, but internationally, right? But there are, for example, nurse practitioners who we are part of the clinical team, part of the health team that also prescribe antimicrobials. So we have to be always vigilant. And of course, the transmission of infection among susceptible hosts. And there's a slide that we're going to see a little later on that speaks to some of these susceptible hosts and even looks further at those factors that influence the surge of what we call community-acquired nosocomial infections, or MDROs, for example. Now, your key preventative strategies, right? We all have to play a part, but we as the clinicians and the health team, we hold the solution, right? So the first thing is that we have to look at prevention of infection. And of course, we look to primary prevention. We're talking about ways in which we can actually prevent disease. So prevention, our grandmothers always say prevention is better than cure. We literally have to look at how we can prevent disease. And so we also have to look at, diagnosing and treating infections early and effectively, as well as the wise use of antimicrobials. And we also have to look at methods or ways in which we can prevent transmissions. Now, in terms of selection of antimicrobial resistant strains, usually within a population of susceptible organisms, you may have a single organism that carries a resistant strain, probably from someone who, let's throw something out there, who had a recurrent throat infection, for example, or ear infection, and this person was given amoxicillin, let's say, for example, or some antibiotic recurrently, and it was the same class of drug being given repetitively, because hey, it works, and the physician or the clinician didn't really think that, let's switch it up a little bit, but they just, that works and it works. So you have the presentation of an organism that carries a resistant strain within the susceptible population, but this is a rare occurrence. And so you have a rare resistant strain. However, when you have antimicrobial exposure and you increase that antimicrobial pressure, what you have happening is that you have the appearance of more resistant strains and less or fewer wild type or susceptible strains, right, that will be in that population. And so through a selective process, we've literally enabled the enforcement or the survival of resistant strains. And that is how we actually have selection of resistant strains within our population. Now, I decided to condense this version this year in terms of how the antimicrobial resistance occurs. But essentially, we have different methods through which you can have your organism, resistance coming about. You can have your conjugation. You can have, among many other things. But the conjugation is one of the ways that you have more effective transference of this mutation, right, for this resistant strain, right? So one of the ways in which it does it is through the use of plasmids, and your plasmids are rings of extra chromosomal DNA that can be transferred between different species of bacteria. And these are what carries the resistant genes. Now, this is the most common and effective mechanism of spreading resistance from bacteria to bacteria, and this is called bacterial conjugation. So all you need to know is that one of the vehicle that transports or carries this resistant genes, they're called plasmids, and they are transferred through what is called conjugation. And the term in and of itself is a little bit self-explanatory. And this is the most effective way in which resistance occurs. Now, in terms of your beta-lactamases, what are they? As you mentioned before, they are enzymes that are produced by certain bacteria that provide resistance to certain antibiotics. And these antibiotics are those that carry a beta-lactam ring, right? And so these are produced by both gram-negative and gram-positive bacteria, and they are found in both chromosomes and plasmids. And so your beta-lactams, example, your penicillins have a beta-lactam ring. So things like your amoxicillin, your penicillin, your ampicillin, your cephalosporins, things like your cephalexin, your cefuroxime, your ceftriaxone, and your carbapenems like your imipenem and your meronym, right? All these drugs have beta-lactam rings. What does this imply? Your organisms, or the organisms that carry an extended spectrum beta-lactamase, they are capable of rendering all of these drugs that you're seeing on the screen incapable of exerting its effect. And so the mechanism of action is that what your beta-lactamase does in terms of the enzymatic reaction is it hydrolyzes the beta-lactam ring, right, of the basic penicillin structure. And this hydrolysis, adding a molecule of water and a carbon-nitrogen bond with the enzymatic reaction, this opens up the ring and it essentially makes the antibiotic drug, ineffective, right? So here, your resistance in terms of your extended spectrum beta-lactamases, the resistance that produced through the actions of beta-lactamases, right? Essentially the extended spectrum cephalosporins, such as your third generation cephalosporins, were originally thought to be resistant to this hydrolysis of your beta-lactamases, but we found that this is actually not so. In the mid-1980s, it became evident that the new type of beta-lactamase, right, was being produced by your Klebsiella and your E. coli and could hydrolyze the extended spectrum cephalosporins. And so they are collectively termed as your extended spectrum cephalosporins, beta-lactams, because they're beta-lactamases, because they're able to easily destroy that beta-lactam ring and render the drugs ineffective, right? So the story is a little bit more complicated, right? Because multiple microbial resistance is often characteristic of your extended spectrum beta-lactam, producing gram-negative bacteria. And so drugs that are usually affected are these drugs here, your ceftazidime, your cefotaxime, right? Your roquefin, right? Even your aztreonam, right? All these drugs, genes encoding for extended spectrum beta-lactamase are frequently located on the plasmids that also carry resistant genes for your aminoglucosides and for your tetracyclines and your Bactrim, right? And your chloramphenicol and drugs like your fluoroquinone. And if you realize that, if you look at this screen, you'll realize that a lot of these drugs are drugs that are in use here in Jamaica in a very frequent manner. And so this is why it is important in our setting for us to be aware of these things. Now, if an extended spectrum beta-lactamase is detected, let's just understand this, that all penicillins, all cephalosporins, and your aztreonams should be reported as resistant regardless of what the in vitro susceptibility tests reveal on your antibiograms, right? And your antibiograms are usually, a test that is done, to identify what are the circulating organisms that are within your region, usually by cases coming into the hospital, et cetera, et cetera. And so your extended spectrum beta-lactamases producing organisms will still be susceptible, however, to your cefamycins, such as your cefotaxime, your cefotetan, and your carbapenems, such as your meronym, right? And so your carbapenems are becoming the therapeutic option of choice, right? And we have seen an emergence of your carbapenem resistant Klebsiella and other enterobacteriae, right? Including your Escherichia coli, right? So what's the take-home message? Your extended spectrum beta lactamases are usually harbingers for your multi-drug resistance. So it heralds your multi-drug resistance occurring within a region or a zone. So this is something that must be taken into consideration. Now, in terms of our antimicrobial resistance, in terms of key preventative strategies, right? We have the pathogen, and the pathogen causes an infection, and of course we therefore use our antimicrobials, and based on our use, whether we have prejudicious use or not, we have antimicrobial resistance. And so, this is what leads to resistance. This is what leads to resistance within a susceptible pathogen, right? Now, what are some of the preventative strategies? Well, before we get to an infection, right, during the natural history of disease, there is a point at which there is something we can do about the disease, right, which is called the critical point of any disease. And so before we reach the critical point, we have screening methodologies, we have primary preventative strategies, including the use of vaccination. And I'm not talking about the COVID-19 vaccination, because these are not primary preventions, but I'm talking about vaccines that can actually prevent disease. They're designed in such a way to prevent the disease. And we're talking about, for example, the strep pneumonia vaccine. We're talking about things like these are not necessarily bacterially caused, but even your measles, your mumps, and your rubella, right? These are vaccines that usually offer what we call primary preventative strategies to give them or offer them to persons who are susceptible, free of disease, and this should prevent them from ever being infected. And so if we have more vaccines, such as your strep pneumonia, your pneumovax, I believe is the name, one of the names, the circulating names of that drug, that vaccine, you will be able to prevent your strep pneumonia infections in patients that are susceptible. So that is one strategy. But then, we won't be able to prevent disease, and not all your fail-safe mechanisms in prevention is actually going to be effective. And so when you do have these breakthrough illnesses or illnesses that just occurred naturally, right, then we have to look at effectively diagnosing and treating the patient. And I want to just make a little caveat here where, I'm going to use the patient who is catheterized, who goes to his catheter clinic, but he comes to the primary care setting. And a part of seeing a patient, a part of being seen in the primary care setting, the vitals are oftentimes done for the patient. And a part of that vital strategy is that they also conduct what's called a urine dipstick. And so in a patient who is catheterized, you see a patient who has leukocytes +++, 4+, you have nitrites positive, trace blood or 2+ blood, 3+ blood, whatever it is. And this patient has, blood trace protein, glucose is negative. This man has an indwelling catheter. What would be the next step? What would you do with a patient like this who has an indwelling catheter, right? What would be the next step to this? Some persons will look at it and be like, boy, this looks like, it's infected, and so we need to jump on treatment. But no, not necessarily. In a patient with an indwelling catheter, we have to understand that we don't treat complementary exams, or we don't treat what we call supportive exams. We treat patients. And so the diagnosis of a patient is made effectively by using, a history, physical examination, and, your complementary exams. Now, in the patient, when you're doing your history, this patient says to you, boy, I'm having some abdominal pain. You need to, explore that abdominal pain in a very decisive and effective way. So you want to ask, what type of abdominal pain is it? Do your Socrates on that abdominal pain, the site, the onset, the character, right? Radiation, all those things. And after doing a thorough history, this patient tells you that his pain is actually in his epigastrium. He's on a ton of medication, right? He's having some gastritis-like pain right now. But you explore his urinary system, and he says, well, doc, I am not having, I'm not feeling any burning or anything like that, but I'm having frequent blockages, and the doctors at the urology clinic are actually planning an intervention to insert a suprapubic catheter because of his recurrent blocks. In this patient, you don't necessarily have to treat the patient, because I can tell you, you send that patient without symptoms, without any urinary symptoms, with a dipstick that is all over the place, including having a nitrite positive. You send that sample, to the lab for investigation, you're going to get a multiple organism growth, which will indicate some form of contaminant. And so the effective diagnosis and treatment, right, we have to be aware at all times, what we're doing with the patient and how to effectively diagnose and treat a patient. Now, in catheterized patients, if they're not having any symptoms, we usually leave them alone, because putting the patient on any form of antibiotics, which they right off the top of your head, this 75-year-old patient, male patient with an indwelling catheter, you're probably thinking of giving him a fluoroquinone, or you're probably thinking of giving him empirical therapy with either Bactrim or with some form of combination penicillin with your clavulanic acid, or you go directly to cephalosporin. And this is exactly how we actually promote, right, the formation of resistance. And so optimizing the use of antibiotic, having, directed empirical therapy towards specific infections is another strategy that we can use. And of course, we also have to do direct therapy, because empirical therapy is empirical therapy. If you start the patient on medication and the patient has not improved within a 48 to 72 hour period, then you have to consider, treating that patient specifically. And usually in best practices, when best practices are employed before you start the patient or commence the patient on antibiotics, you should actually have a culture done. So by the time you are at that, second to third day transition, you would have already had some form of preliminary report, should it be blood, or you would have already had a urinary culture back within 24 hours to inform your antibiotic choice. And so optimizing your use of antimicrobials is definitely one of the ways to prevent resistance. And of course, prevention of transmission through, all of the barrier protections, which I won't go into because I know that there's a talk that speaks specifically to prevention, but these are just some of the strategies that we employ in doing so. So I did some reading and I realized that everyone had a consensus on how to prevent antimicrobial resistance spread in hospitalized adults, and this was among adults. And there were like about 12 common factors or strategies rather that I saw, and I just decided to just put them in. And so, primary prevention is vaccination, getting your indwelling medical devices out as soon as possible if they are not warranted. So for those who are in the OT setting or the ICU setting or post-recovery, or we call it recovery setting, in hospitals, one of the things that you'll realize that some of the surgeons like to do is that they like to take out the urinary catheter as soon as possible, right? And so this is very important because colonization can and will occur. And boy, Murphy's Law, stands strong when it comes on to medicine. If anything will go wrong or can go wrong, it will. So, as much as you can, prevention is key. And I already spoke about vaccination, with your vaccines that prevent disease, right? This is an effective way of actually stopping microbial resistance. Now, I just want to say that in terms of preventing, even the resistance, this is actually one of the most effective ways. Because if you have vaccines that prevent disease, then you will also prevent the mutation of different strains. Now, in terms of diagnosing and treating infections effectively, your targeting of the pathogen is very important, and your access to the experts. And so your infectious disease specialist must be on board. And I know that in other first world countries such as UK and United States, they are actually looking at having multi-drug resistant committees, like surveillance committees, right, within their hospitals, right, geared towards prevention of this within the hospital setting, the nosocomial setting. Now, the use of antimicrobials wisely, we've already looked at some of these. Practice antimicrobial control, or the wise use of same, utilizing local data by looking to your antibiograms, treating infections, not contaminations. Treating, pardon me? Okay. So, to treat infections, right? To treat infections and not contaminations, which was one of the examples I mentioned earlier with that gentleman with an indwelling catheter. And also to know when to say no to vanco, right? Stop treating when infection is cured, or when you recognize as the member of the healthcare team that the infection is more than likely unlikely, right? And so prevention of transmission, which is to isolate the pathogen and breaking the chain of contagion, right, is also one of the effective steps. Now, we already spoke of vaccination, which I'm not going to dwell there because we've already looked at it, right? And so the need for healthcare personnel immunization, right, in terms of influenza vaccines, right? And we know that influenza vaccine prevents the strain of the vaccine that it actually is designed for, but it offers some cross protection, right, against the subsequent strains or future strains, right? And this is, if you're a healthcare worker over the age of 65, right, what they found out in terms of this study here in the US was that they had about 63% of their healthcare workers above 65 that were actually vaccinated. The healthcare personnel at high-risk stations, right, they're about 38%. And all healthcare professionals, in terms of a median of those vaccinated with the influenza vaccine, was about 34%. And what does this mean? I mean, it just, some persons are willing to go, some persons aren't. And, but vaccination really, really helps when it comes on to patients who are healthcare personnel, right? Now, for the need for hospital-based vaccination, right, in post-discharge vaccination status of your hospitalized adults, and this was for patients who were at risk, right, for strep pneumonia, right? You realize that the younger age groups, right, did not have much vaccination uptake for your pneumonia, right, as opposed to your influenza vaccines, right? And your over 65 had the largest uptake, right? And so usually your strep pneumonia vaccines are recommended for patients who are elderly, so the very young and the very old, right? Especially those who are carriers of the sickle cell gene and that sort of things, right? Now, for persons hospitalized for pneumonia during the influenza season, right, that sort of vaccination uptake was also, very, very, very poor, right? But it's important for us to understand that having these type of primary prevention, and when I say primary prevention, I mean your agents that actually prevent disease, they are actually very effective in stemming the disease itself, but also halting back MDRO or multi-drug resistant organisms. Now, in terms of getting the catheters out, catheters and other invasive devices are the #1 exogenous cause of hospital onset infection. And I will repeat that, or I don't need to repeat it. But this is more important because, or this is even more important because in our current situation, our society, we actually have what we call a demographic shift, which means that our population is aging. And as a direct effect of our aging population, we also have the incidence and prevalence increased for non-communicable diseases, right? And so you're going to have an uptick in your patients with end-stage renal diseases. You're going to have, because patients are living longer, right? I remember one of our professors said that yes, we're living longer, but boy, the disease are getting stronger, right? So it's just a way of saying that, you know, because the patients are living longer, you're going to see more of these geriatric or age-associated type illnesses. So you're going to find more patients with your, you know, prostatic hyperplasia, right, which may compromise their bladder outlet activity, requiring a catheter. And so frequent changes. I've seen patients in private practice where they have had catheters in for 4, 5, 6 months, right, without having a catheter change, right? And so that is just unacceptable, because these are things that promote colonization. And I mean, if the patient doesn't need it, then take it out, right? In terms of targeting the pathogen itself, we've already looked at that in terms of empiric therapy, but also looking at definitive therapy, looking at the susceptibility of the organism. But remember, once there is the presence of an extended spectrum beta-lactamase within your area in a particular organism, you have to look at the drugs that are, even though the antibiogram might say that the sensitivity spectrum might say that it's sensitive, you have to remember that all your penicillins, cephalosporins, are thrown out the window, right? Automatically. Now, here is a, sorry, let me just get this out of the way. Right, here is, we're looking at your inappropriate antimicrobial therapy. And so we have patients who have survived, we have patients who have died. And so essentially, your patients who have had the appropriate antimicrobial therapy, right, versus your inappropriate antimicrobial therapy. When you look here, approximately 42% of those patients, I'm sorry, this was supposed to be down here. 42% of these patients died, as opposed to 17.7% of those patients actually survived, right? Actually died. And so in terms of the relative risk of dying with the inappropriate use of antimicrobials, you had a 2.37 times, you're 2.37 times more likely to die from complications of a multi-drug resistant organism, right, if there was inappropriate antimicrobial therapy. And this was with an appreciative confidence interval, 95% confidence, width of a confidence interval, and P was less than 0.001. And so in terms also of the source of your prevalence of inappropriate antimicrobial therapy and the patients where they came from with infections, you realize that in the community onset infection you had 17.1% versus your purely hospital onset infection, which was 34%, which is roughly half of what your community acquired onset infection. And this is with your multi-drug resistant organisms. Now, this was done in a study of 655 patients within the United States. And what they found also was that, and interestingly enough, 45.2% of patients who had infections, right, that were considered MDROs, right, were actually patients who had hospital onset infection after they initially had a community onset infection. And so this was one of the things that highlighted the fact that there is a growing number of patients coming from the community who are having multi-drug resistant organism infections. Now, this is something that is of great concern to public health, because usually your MDROs are infections that you find within the hospital setting. And so they're usually considered nosocomial infections. And so we usually look for them to be, affecting patients who are in the hospital setting. The criteria for determining a patient who has a community acquired, they call them CA MDROs, right, as opposed to a nosocomial acquired MDRO, is that if you do a culture on admission within the first 48 hours of the patient being in hospital, and the patient actually has this organism, then it's, after manifesting symptoms clearly, we can safely say that this was not acquired in hospital. And so, as I said to you before, we are seeing more and more of these cases, right, that are coming from the community who are presenting with multi-drug resistant organism. So in terms of diagnosing and treating effectively, one of the things that we have to look for is the access to experts. And so your infectious disease expert input involves the outcome of serious infections. And so getting their expertise on a matter is always of grave importance. And so your infectious disease expert resources are your infectious disease specialists, your infection control professionals, which we have here in Jamaica. We have a lot of infection control nurses, right, and infectious disease nurses, and I'm really happy about that. We have to have our clinical pharmacologists to actually look at how the strategy, at how to rotate your antibiotics availability based on the organisms that are circulating, that to reduce the impact of resistance. And your surgical infection experts, your clinical microbiologists, your clinical pharmacists, and of course your healthcare epidemiologists, which will all, we are looking at optimizing patient-centered care. And so all of this will pool, all these resources will pool into optimizing that care. And so in terms of our practice, the use of antimicrobial wisely and antimicrobial control, programs to improve your antimicrobial use are effective. And the use of local data is also very important. The prevalence of resistance can vary by time and locale and patient and population and hospital units and the length of stay. All of these factors impact your prevalence of resistance. And so having monitoring systems for these will definitely be of great help. Now, in terms of treating infection and not the contamination, the fact is that a major cause of antimicrobial overuse is treatment of contaminated cultures. And so, just like that patient who has this indwelling catheter who had a very colorful urine dipstick, right? Let us not forget that we have to diagnose, or diagnosis is made by 3 agents: or history, or physical examination, and our complementary exam. So we don't treat complementary exams. So always ensure that you get a proper history. Always ensure that you use proper antisepsis for blood and other cultures, the culture of the blood and not the skin or the catheter hub, and the use of proper methods to obtain and process all cultures, right, are also important. And the treatment of infection and not colonization, which is what I just mentioned, sorry, and the treatment of bacteremia, not the catheter tip or hub. We treat pneumonia and not a tracheal aspirate. We treat the urinary tract infection and not the indwelling catheter, right? We also have to know to say when to say no to vanco, because vancomycin overuse promotes also the emergence of vancomycin resistant strains, right? Now, I just want to show you just the evolution of vancomycin resistant strains, right? Or your methicillin, sorry, resistant strains. So in 1950s, right, when we had the penicillin, right, when we had Staphylococcus aureus, we introduced penicillin, and then you had penicillin resistance. Then by 1970s, because of the fact that we had penicillin resistance, they had penicillin resistance in the States, they introduced methicillin. And this is where they developed that methicillin-resistant Staphylococcus aureus within the 1990s, right? So within a matter of just 30 years, right, we were now at the door of having methicillin-resistant Staphylococcus aureus, which is MRSA, which you all know. And then in the 1990s, your vancomycin was introduced, and then you had your vancomycin resistance within a 7-year period, right? So it took 20 years to be effectively resistant to penicillin, another 30 years to be resistant to methicillin. And now vancomycin, it only took about 7 years to have your vancomycin intermediate resistant Staph aureus. And by 2002, we had our fully resistant vancomycin Staph aureus, right? So the use of antimicrobials wisely is definitely a very key point. And so we stop antimicrobials when the infection is cured. We stop when the cultures are negative and the infection is unlikely. And we stop when the infection is not diagnosed. If you don't have a diagnosis, then we don't need to use it, right? I mentioned this about the demographic shift, but one of the things I wanted to point out was this, the tigecycline use in patients with carbapenem-resistant Klebsiella pneumoniae, right? And this eventually led to your tigecycline resistant enterococci, or Klebsiella pneumoniae, sorry. And here we also have your ceftriaxone, which has also impacted your enterococci, right? As well as the vancomycin resistant organisms. Now, in terms of your indwelling devices, we already mentioned that, and we're looking beyond just the urinary catheters. We're looking at the, temporary catheters for the renal patients on dialysis, and they are a special group within themselves because the amount of, a lot of times you have, catheter site sepsis, right, which is something that is very prevalent. We have our permanent catheter patients. We have patients who, because of the aging population, we have patients who are suffering more from cancers and have to do chemotherapy. And so all these catheterizations and tubes and proddings and pokings, right, are also risk factors for infections. Now, I also have to mention your immunosuppression or immunosuppressed states from solid organ and stem cell organ or stem cell transplant recipients. These patients tend to also be very susceptible to what's considered a community-acquired MDRDs, right, which is considered an emerging trend. Now, isolating the pathogen in terms of preventing transmission, which is the 11th step, is to prevent patient-to-patient spread of pathogens, right? Now, the use of standard infection control precautions, as we all know, is very, very important. And we're also looking at the control of contamination of infectious bodily fluids, right? And so we have to understand the difference between an organism that is, transmitted through airborne transmission, droplet transmission, contact transmission, right? So we can adhere to all of these precautions, which I know that presentation is going to be excellent, right? Looking at all of these IPC precautions. Now, when in doubt, consult the infection control experts, right? Always, never be afraid to consult or seek help if you're not sure. And the healthcare personnel, right, in terms of breaking the chain of the contagion, right, the healthcare personnel can spread antimicrobial resistant pathogens from patient to patient. And this was, I don't know if you guys know about the story of Ignaz Philipp Semmelweis from the 1818s to 1865. He was a physician who noticed that they were having a lot of postpartum deaths. And so they realized that the mothers who were examined by doctors and medical students were dying more than the mothers who were delivered, by medical students and doctors, were dying more than the mothers who were being delivered by midwives. And, I like to tell this story specifically given the detail because a lot of persons just give you the condensed version, right? But I also want to highlight the importance of the contribution that nursing has added to the healthcare professional, right? Or the healthcare or health system, in that the midwives were having a very small death rate, right? In comparison to the physicians and the medical students. And so Semmelweis did an observation and he realized that the medical students and the doctors would go and do autopsies, and then they would go and deliver the babies while the midwives never partook in autopsies. And what these physicians and medical students would do is that they would go, having done a post-mortem, go and deliver a baby without, washing their hands. The midwives, he noticed, however, always wash their hands with an antiseptic solution, a chlorinated lime solution that they had in between delivering patients. They didn't do it all the time, right? But they did it in between delivering patients. And I guess those were the times when, you would have a maternal mortality or a postpartum mortality. And so Simoes summarized that, hey, there are cadaveric particles that are killing the mothers. And so they call it postpartum sepsis or postpartum infection. And so essentially, nobody really believed him or took him on because they thought he was a madman. And he eventually, to prove his point, I think he cut someone in the morgue and they got infected, and he was a male and he died from postpartum sepsis. And they still didn't believe him until he actually infected himself and died from postpartum sepsis. And then they realized that, hey, there was some truth to what he was saying after he died. And so they implemented the routine hand washing with the chlorinated lime hand antisepsis between patients. And so I just want to highlight just how important the midwives were in terms of, and nursing was in terms of instituting a very basic process, which is hand washing, right? So prevention and control of your MDRO transmission, your successful control of your MDROs have been documented using a variety of combined interventions. And these include improved hand hygiene, something as simple as that, use of contact precaution until patients are culture negative for targeted MDROs, the active surveillance cultures, your education for both healthcare workers and the patients, and as well as the enhanced environmental cleaning and improvements, right, in the communication about patients with MDRO within and between their healthcare facilities. Now, in terms of perspectives, I just want to bring your attention very quickly before I close to Palestine, right? They have a serious problem over there where they have unrestricted use of antibiotics in the community. They have a very high MDRO prevalence rate, and it's because of a lot of these things. The role of physicians in evidence-based guidelines and protocols is not very strong. The role of your pharmacists in terms of advising policies is also not very strong. And the public education, public health education is also not very strong. And it's coming all the way from the top because the Ministry of Health itself, in terms of their rules and regulations and enforcement, also is practically non-existent. And so because of a lack of a national nosocomial infection surveillance system in both government and non-governmental facilities, there is, a lot of issues going on. And so not enough infectious disease experts as well and resources, your infectious disease specialists and everything that we had highlighted earlier. And so this is one of the things that are a lot of the factors that compound the current problem currently in Palestine. Now, the prevention is primary. And so we have to protect the patients, protect the healthcare personnel, and promote, quality healthcare. And I just want to say thank you for your time. And that is all for today. Here are my references. And thank you very much.
Okay, Dr. White, thank you for a very informative and interesting presentation. Do we have any questions at this time? You can type it in the chat, or you can go to the reactions and raise your hand. Any question? Comment? Very well done. Do we have any questions? Let's see. Yes, I'm seeing a hand. Excellent presentation. Dr. White, very interesting and informative. Excellent presentation. Oh, someone is saying they love the midwifery story. Sadly, that is still occurring. Very informative. I'm really enjoyed. Okay, Miss Crystal Lee Brown. Okay, we have no questions at this time. I'm inviting our president, Mrs. Garrix Lloyd, to come at this time, just to have a chat with, oh, I'm sorry, Miss Peter Gay. Please go ahead. Go ahead, please. Unmute your mic,
Yes.
Peter. Okay.
Yes, good evening. As we're talking about drug resistance, does having a protocol, like my hospital has a protocol for first line, second line, and third line and fourth line antibiotic, contribute to multi-drug drug resistance? Because at first, they start with the first line antibiotics, and until we get the results of the culture that would direct to a specific antibiotic. Does that in some way affect drug resistance?
So I thank you, Peter Gay, for that question. And most hospitals will have a guideline. And remember, guidelines are exactly that. They guide our actions as to the types of drugs that we will use. And as you rightfully mentioned, the first line, second line, and third line. It doesn't necessarily contribute to multi-drug resistance having a guideline, because what it actually does is guide your physicians as to what to do, what medications to use. And usually these guidelines would or ought to be informed by the antibiogram coming out of the office of the medical microbiologist, as well as the pharmacologist, the pharmacy personnel, the clinical pharmacist who is also there. Having a guideline doesn't contribute to MDROs. What contributes to MDROs is the excessive use of antibiotics when there is no culture, when we don't know what we're treating. And I have seen cases where patients have been treated with 6 different antibiotics. And when asked, the physician doesn't know what he's treating. He says the patient is having a fever, white cell count is elevated, something must be going on. Let's throw a nuclear bomb at it. And this prejudicious use of antibiotics, regardless of having a guideline, are the factors that contribute to MDROs.
Are you okay, Mrs. Brown Spence? Did he answer your question? I think you did. Are there any other questions at this time? Oh, she said yes. Okay. Okay, there are no other questions, just commendations, Dr. White, about your presentation. It's very clear and understandable. Okay, thank you once again, Dr. White. I got it right this time, not Knight, White. Okay, all right, Mrs. Garrix Lloyd, our president of Omega Kappa, I invite you to come at this time.
Thank you so much, Mrs. Silvera. Never mind Dr. White, I had a classmate named Right White and we had a Brown White. So there was a debate on who was the right white, right? So these things will happen. Thank you so much to you and both you and Sharika. The comments from YouTube were similar to here, informative, clear, and they perfectly understood and an opportunity to learn more about the microorganisms and the microbials, and somebody over there loved the midwifery story as well. So thank you so much for joining us for the start of our second webinar series. And similar to before, we would close off with just a quick presentation about our chapter. But I'm not sure if Dr. White had any questions. Last time we started with the trivia and my moderator this time said we should wait a little bit to do them. So I'm not sure if Sharika, is she still here, Miss Natty? Are you still here?
No, she's not here at this time.
All right, because now I don't know the answers to these questions, that we were supposed to ask. So how can I determine who's going to win the prize? Right, there are 2 questions. So I'm going to ask because persons were listening clearly. the first question. So we are waiting on 2 people who will give the correct answer. Dr. White, if you have any, you can just send it over to me in the meantime. It says, what fraction of the world's food is estimated to be lost or wasted each year? So that's question 1. We want both correct answers, and then we will have to discuss what the prize is before my presentation. What fraction of the world's food is estimated to be wasted or lost each year? And then the second question, what are the 4 conditions or steps in Koch's postulates? So while you're thinking about that, I'm giving the persons on YouTube an opportunity to answer as well. Question?
I'm seeing the first answer.
That's all right. We're waiting on 2 answers. I'm going to go over to YouTube, but I'm going to read it again in case somebody never heard. Question 1. What fraction of the world's food is estimated to be lost or wasted each year? Question 2, because we need both answers, not just one. What are the 4 conditions or steps in Koch's postulate? And so we're only giving 30 seconds because we know that people are going to probably be checking on Google right now to get those 4 conditions, right? So let me just quickly go over to YouTube and see if they're answering over here. All right, so we're giving them just a little bit more time. Those are the 2 questions that we have. All right, so let me wait, and while we are looking in the chat, Mrs. Silvera, monitor that for me so that we are able to know who it is. Let me go right ahead and share my PowerPoint. Dr. White has put his question, so we need 3 answers. All right. Thank you so much, Dr. White. There you go. Great trivia. Mrs. Silvera, pay attention. We need 3 correct answers to be able to give out the prize by the time I'm done. All right, so let's just tell you a little bit about Omega Kappa. For the members who know, they know. For some persons, they may not know, and we wanted to share who we were. We thank you so much for supporting our webinar series. Yes, it is something that we are doing, but it's also something for our health profession. So let me just move this a little, and then I'll be able to share with you. So in 1922, our organization started at the University Training School for Nurses at the Indiana University School of Nursing in the USA. There were 6 little nursing students who wanted an extracurricular activity to partake of that fit in with their studies of nursing. They didn't find anything, and so they started the Sigma Theta Tau International Honor Society of Nursing. So they're actually celebrating 100 years going towards this year. And so they chose the Greek names Storage, Tharsos, and Time, and it means love, courage, and honor. So Sigma, as it is called now, instead of saying Sigma Theta Tau International Honor Society of Nursing, is a nonprofit organization, and the headquarters remains in Indianapolis, in Indiana, in the USA. So this is the vision and the mission of Sigma. Their vision is to have connected, empowered nurse leaders who transform global healthcare. And the mission is to develop nurse leaders anywhere so that we can improve healthcare anywhere. Now, membership is comprised of undergraduate, graduate students, and nursing leaders. Potential members who meet our eligibility criteria are invited to join. Usually it's by invitation, or persons can actually apply to Sigma's site themselves. They are looking for excellence in scholarship, leadership, and service. And so they're wanting us to be having members who we are able to see shining in those areas. Currently, we have over 135,000 active members with approximately 540 active chapters in over 100 countries. So if you're interested as an undergrad student, Sigma asks that you be enrolled in a current nursing program or equivalent. You need to have academic excellence based on the criteria of your institution, should be in the top 35% of your class, and should have completed at least a half of the curriculum. We do have some programs that move students who were not doing degrees initially. So if you're doing the RN to the BSN program, then you should have done at least 12 hours. If you're a graduate student, they're asking you to have completed a quarter of your curriculum. And again, the academic excellence based on the set criteria, and you should meet the expectation of academic integrity. And for nursing leaders, we want them to be legally recognized to practice in their country. They should have a minimum of an undergraduate degree in nursing or any equivalent field. And we need to see demonstration of their nursing achievement, again, in the 3 areas of scholarship, leadership, and service. So joining our chapter or Sigma gives you the opportunity to be exposed to career mentorship, to access our nursing professional development courses. Sigma has an extensive e-repository of research and presentations. They have academies, writing academies, leadership academies, and nursing academies, the opportunity to publish. Sigma has 2 of the highest rated nursing journals, and they also have what they call the Nursing Center. They have a podcast and a webcast. They have the opportunity to access research grants. The networking is awesome, and they also have a lot of volunteer opportunities, not just in your chapter, but in Sigma overall. And there are annual and biennial conferences, lots of webinars that have been open to non-Sigma members, especially during the pandemic. And so those are just some of the benefits. So this is Omega Kappa. This was our chartering day. So over 25 years ago, we had a visit. We just completed a Sigma International Convention, and the past president, who was a part of the conversation, she was so happy. She said, it has only been 25 years. We are chapter 560, and we are currently geographically located in the UWI School of Nursing, Mona, at the Kingston campus. We have membership, however, across countries. And so we have members here in Jamaica, in Trinidad and Tobago, in the Bahamas, in the US, and in England. We were chartered on the 30th of May, about 2.5 years ago, and we do have nursing leaders and nursing students. And for all our OKs, we just want to share we are an award-winning chapter twice over in our 2 short years. So we're just sharing a little bit of our pictures about who we are. Our initial convention in 2019, participating in the Guardian Group 5K, participating in the International Coastal Cleanup Day. This is me with some of my students who are now my colleagues at our chartering ceremony. We have an annual World Mental Health Day activity and an annual health fair. That's October and August, respectively. We've been on the radio station from across the campus, but it aired on several stations. We had our inaugural virtual session last year about COVID and its impact on nursing. We had another one this year. This is us looking cute after a tiring 2 days of health fair at the launch of the Year of the Nurse. And this was our first virtual induction ceremony last year. Everything has changed due to COVID. And this is the latest 2 that we had. I was nominated and awarded as the Sigma Outstanding New Member Awardee for 2021. And our chapter received the Excellence Award from our region, which is Latin America and the Caribbean. We had our recent mental health day activity, and we also had an evening of remembrance and reflection in honor of all our colleagues that we've lost across the Caribbean from COVID. And this was convention we concluded last week. That was me being recognized for my award, and our chapter also won the Chapter Key Award, which is an award of excellence given to chapters based on meeting Sigma's criteria. It was an achievement for us as we are only 2 years old. Based on what they said, it sounds like that's not something that usually happens. And so currently we are working on adding to our membership benefits. We are actively participating in the Sigma Global Communities and Academies, working to collaborate across groups and organizations, nursing and non-nursing, trying to increase our visibility, to increase our membership and to retain those we have. And certainly we are hard at work trying to ensure that we are maintaining the mission and vision of Sigma, and particularly trying to impact nursing and healthcare in our region. So for nursing students and nurse leaders, in addition to the requirements from Sigma, our requirements include an application letter, transcript and recommendation letters too, for the nursing students and for our nurse leaders, an updated resume with the letter and 2 recommendation letters, including one from your current place of interest. This is how you can find us. Sigma's website is sigmanursing.org. Our website is omegakappa.sigmanursing.org. We're on Facebook as the Omega Kappa chapter. We're on Instagram as Omega Kappa Caribbean. We have a YouTube channel, the Omega Kappa chapter of Sigma, and many of you would have emailed us. So please feel free to contact us at omega.kappa.chapter560@gmail.com. We are waiting to hear from you. We want you to be a part of this excellence in nursing journey so that we can impact ourselves, our profession, and healthcare. Just a reminder from our CEO, Dr. Elizabeth Madigan, never forget the light you bring, the difference you make, and the lives you change. We heard the story just now, and this was our chartering day, I believe. Was this our chartering day? Yes, it was.
Yes, it was.
Yes, so that was us. Thank you for listening to us. And if you have any questions, we'll take those before we close off our session this evening.
Okay, I'm not seeing any questions. I think we have a winner.
All right.
Miss Joni Valentine, she was the first to type in the chat. Number one, she said a third. Number two, she said must be cultured or be present, must cause the disease when introduced to healthy organism, and it can be re-isolated. Is she right? Is she correct?
That's 3. I think she said 4.
4? Okay, what she gave?
Yeah, she said out of 4 from Cox, it was 4.
Okay. Let me see. I don't think anybody surpassed. Let me just look again.
All right. I see a Teresa Magal, and I think she has 4 things there.
All right. Let me read for you. Teresa Magal has a third of the words food. The 4 criteria are, okay, 1, the microorganism must be found in disease, but not healthy individuals. Number 2, the microorganism must be cultured from the disease individual. And 3, inoculation of a healthy individual with the cultured microorganism must repeat the disease. And 4, the microorganism must be re-isolated from the diseased individual and matched to the original microorganism. So it's
all right.
4. So that would be Miss Teresa Magal.
All right, wonderful. Joni, you did have 4. She's saying she had 4. And did anybody answer Dr. White's question, which he placed in the chat?
Jody said she had 4.
No, I sent it to you, Cheryl.
Oh, so they never saw it. I was to read it out. Oh, my word. All right, so we're going to have to keep that question for Thursday. And so we will double check. Both Joni and Teresa should know how to find me. Please send me a message and we will double check your answers and let you know what you have won. Thank you everybody for participating. Let us just read those answers out again. And you know what, Dr. White, we could give your questions as homework, you know, right? Yes, we are nurses, you know, homework educator.
Do you want the persons to kill me, but that I came here giving them homework?
No, it's not you. I'm giving the homework. List 4 of the 12 methods of preventing MDROs. So persons should be able to know that 4 of the 12 of preventing MDROs. And the second question is, why does the appearance of extended spectrum beta lactamases indicate in your, what does it indicate in your health region? Is that correct, Dr. White?
Yes, it is. Yes, it is.
Wonderful. So those are the 2 questions. And so it means that even if we don't give a prize for that, person should go home being able to respond. What are 4 of the 12 methods of preventing MDROs? What does the appearance of extended spectrum beta lactamases, EBLs, indicate in your health region? We thank you all so much for joining us. Just a little bit of public service announcement before we close again. We are reminding persons, the sessions are 2.5 hours each. 4 sessions that will look at infection prevention and control, 2 sessions that will cover 2 separate non-nursing topics. The registration form will close 24 hours before each session. So we're reminding the persons who have joined us who have not completed their registration When we reopen tonight, please go ahead and complete it. We need it for records and to mark you present or not. 2, if you have registered and you did not email us, we are reminding you the instructions asked that you email a copy of your payment receipt to our chapter's email address so we can send you the Zoom or YouTube information. And 3, there are some persons who are here tonight who have put names as joining, and those are not the names they used to register. We are marking you based on your registration. So if you registered double-barreled and you joined with just one name here, we may not have you present. So we're asking you again to tell everybody, you come into this session, we're gonna mark the register. We can't give ours to somebody who is joining with just half a name, one name, or with the phone's name. You won't be able to verify who those persons are. So we ask you to ensure you follow all the steps. We want you to get the information. We want to be a part of impacting healthcare and nursing. We want you to join us for all our other sessions. So those just a little bit of public service cleaning up. We thank you so much for joining us. And remember, we will see you again on Thursday. We're asking you to ensure you complete your registration and that you are ready and waiting to share with others. Thank you for joining us this evening. Madam Moderator, over to you if you need to say anything to close.
Just thanking everyone for joining. And as you said, we closed 24 hours before the presentation. And just a reminder, Nursing Council stipulates that you need 10 hours of infection control for relicensure. Thank you and have a wonderful evening. Bye-bye.